Okay, this is an introduction to electric circuits. I'm going to run you through how to draw a circuit, what are the components, and how to construct one in the real world. We need a power supply, which is shown here. This is actually a drawing of a cell, but we're going to call it the power supply today. We need a switch in our circuit, which is going to open as it's shown here. And when it shuts, it's going to allow the electricity to flow all the way around this circuit. We need a wire. Now, wires are what we call conductors. They're really good at transferring electricity without slowing it down at all. And what's inside these wires is copper. It's an excellent conductor. So it's going to transfer the electrical energy through the circuit. We also need something in our circuit to use up the energy. In this case, we're going to use a simple globe as I've shown here. And then, as is commonly not understood, that circuit is actually going to have to come back to our power supply to complete the circuit. If that is not done, then the electricity will not flow in that circuit. A few features of our power supply are it's got its own switch here. It's also got options for direct current, that's DC, or alternating current, which is AC. Today we're going to use DC because that's how our meters are going to measure in. We've also got a voltage here which we can change from 2 volts all the way up to 12 volts. Now we're going to demonstrate why you need a full circuit going from the power supply to the resistor and back again in order to get some flow happening. So if I simply connect one cable to the light globe, it won't actually light when we turn it on. However, if we then connect it back, we have what's called a circuit. Now notice my circuit here doesn't have a switch. I'm just going to rely on this one here. But now when I turn that on, we get electricity flowing through this circuit and the light globe is lit up. Here we have all our components, but this time we're going to have 2 globes. And notice they're in what we call a series circuit. That means they're all in a series and there is no branches in this circuit. So how do we connect this? Well, as shown here, we're going to have our 2 globes laid out and we want the electricity to flow from one globe to the other globe and back again. So it's quite simple. Just connect it here. Connect it between the globes. And then finally, we connect it back again. Next, we're going to do our parallel circuit. Now you'll notice this circuit has branches, and we find that if we trace around, each globe now has its own circuit. So we would call these 2 globes, they are in parallel to one another. So how do we construct that? Well, first we grab our globes and we'll put them just like our circuit shows. And next we're going to connect them, first of all, this first globe in series, just like we did with our original one. And the second globe, we're going to have to create an additional circuit, just like we have here. Now these connectors, as you can see, have a special hole where you can create those branches just like that. So I'm going to use these 2 holes here to create a second circuit like this. And we're going to see a difference in the globe brightness when we turn it on. As you can see here, one of our globes isn't working. So if that ever happens, we just need to find the component that's not working. Have a little bit of a fiddle with the wires. And there we go, we've got it working. Now we can notice here that just like our diagram shows, each of these globes has its own circuit, and we can follow that along really clearly following the wires. And you'll also notice that each of these globes is now as bright as when we had just one in series on its own. It's equally as bright. So we're going to try and explain why that can be when we've still got the same voltage here. We haven't changed it, and yet now two globes are just as bright as each other as if there was only one globe. Should also be noted that we can have multiple lights in parallel and series in any combination we like. So in our diagram here, we've got one globe which is in series, and it's in series, and it's in parallel to these globes over here. So there's a break in the circuit, which means this circuit here is in parallel to this one here. But as we can see, these two globes here are in series with one another, but parallel to this one. So as we've just learned, when we have a parallel circuit, this circuit does not need to share with this circuit. However, these two globes here will share because they are in series with one another. So let's see what happens when we connect them all up. Okay, here we've got it. Our first circuit is here, and our second circuit is around here. And as you can clearly see, these two globes here are having to share the power, the voltage with each other, but they're not having to share it with this one. This one doesn't have to share with anyone, so it can get the full 12 volts. And if I was to measure the current at varying points, it would show accordingly that these two are sharing the voltage and this one doesn't have to.